When you think of dust hazards, what comes to your mind? You probably think of the hazards of inhaling dangerous products. Thus, why it's so important that we protect ourselves by wearing proper airway protection. However, this training is not about inhalation hazards. Rather, it's about protecting yourself from the flammable and explosive hazards associated with combustible dust. Combustible dust fires and explosions pose a serious problem in many industries throughout the world. And on February 7, 2008, a dust explosion and fire at Imperial Sugar Company in Port Wentworth, Georgia, killed 14 and injured 36. In 2011, a dust explosion and fire at Hoganese Iron Powder Facility in Tennessee killed 5 and injured 3. Unfortunately, these are just a few examples from a long list of similar events. In response to these hazards, Mr. Merritt, chairman of the U.S. Chemical and Safety Hazard Investigation Board, also known as CSB, he declared that chemical dust explosions in the United States are a serious industrial safety problem. The CSB's preliminary research into these incidents revealed that nearly 200 dust fires and explosions have occurred in U.S. industrial facilities over the past 25 years, resulting in approximately 100 fatalities and 600 injuries. However, as is highlighted by the CSB, NFPA, and OSHA, one way to significantly reduce the possibility of dust fires and explosions in industry is through an aggressive education and training program designed to minimize the risk. The goal of this training is to ensure your safety awareness when working in environments where combustible dusts may be encountered, by increasing your awareness of this hazard and by demonstrating how the hazard can be recognized and safely addressed. To help us understand the unique hazards associated with combustible dust, let's look at the science behind the hazard. First, let's explain fire. Fire can be illustrated by looking at the fire triangle. In order for fire to exist, 3 components are necessary: oxygen, found in our atmosphere, a combustible material or fuel, and a heat source that is needed to start the chemical chain reaction of rapid oxidation we call fire. The surface area of the fuel is also important. By increasing the surface area exposed to the oxygen and the heat source, burning will correspondingly also increase or react more readily. Now, to understand the hazards of combustible dust, let's take another look at our fire triangle. Dust in a pile or lying on a surface of something shares a similar surface area and thus similar fire behavior of the product in a non-dust state. To increase the surface area of the dust, all that is needed is dispersal. Upon dispersal, the product becomes very flammable, even explosive, because of the increased surface area of the already combustible material. Most solid organic materials are extremely flammable as a dust when exposed to an ignition source. To illustrate, a wooden sphere with a diameter of 1.5 inches has a surface area of 0.05 square feet. Then if you take that same wooden sphere and change it into dust particles 50 microns in diameter, it now has the surface area of approximately 125 square feet. But how small are dust particles 50 microns in diameter? A comparison can be made by looking at average particle sizes of common materials. For example, table salt averages around 100 microns per particle, where talcum powder averages about 10 microns per particle. According to the NFPA, a combustible dust is defined as a finely divided combustible particulate solid that presents a flash fire hazard or explosion hazard when suspended in air, or the process-specific oxidizing medium over a range of concentrations. If you were to try to light the 1.5 inch diameter wooden sphere, it would be difficult. But look what happens when you disperse the wooden sphere as dust particles and shavings in the presence of an ignition source. Sawdust has a high surface area to volume ratio, while log has a low ratio. Thus, as seen here, the surface atoms can rapidly oxidize much faster than atoms in the interior of a wooden ball. Another way to demonstrate the unique characteristics of combustible dust is with cornstarch. The average cornstarch particles range from 0.1 to 0.8 microns in diameter. Notice how difficult it is to ignite the cornstarch with a torch when it is in a pile. The reason: the surface area exposed to the atmospheric oxygen and the heat source is relatively small. However, when you disperse the cornstarch in the presence of an ignition source, thus increasing the exposed surface area, you can see the drastic change. Now, only for the purpose of science, we wanted to illustrate what happens when larger amounts of cornstarch or dust particles are dispersed in the presence of an ignition source. One more time. Again in slow motion. Even materials that do not burn normally in larger pieces, such as aluminum or iron, given the proper conditions, can be explosive in dust form. The minimum explosive concentration for combustible dust varies according to the particle size and energy nature of the product. However, all combustible dust should be considered very dangerous. Let's again look at our original fire triangle. Previously, we illustrated that dispersion of combustible dust creates the conditions required for a dust flash fire. Now, we will add one more component: confinement, as seen here in the dust explosion pentagon. Dispersed combustible dust within a confined space, with an ignition source and proper concentration of oxygen, results in an explosive reaction. In this demonstration, notice the explosive reaction when cornstarch is dispersed inside a closed can with lit candles. This reaction illustrates the destructive nature of industrial dust explosions, which have devastated buildings and concrete silos. But how does this hazard translate into a hazard at your workplace? Well, each dust has different explosion thresholds. The 29 CFR 1910.22 warns that more than 1/32 of an inch of dust, over 5% of a room's surface area, presents a significant explosion hazard. When dust is allowed to settle on surfaces, an event can disrupt the settled dust into a cloud of dust. In the presence of an ignition source, the dust cloud can be ignited and may even be explosive. The force from such an explosion can cause employees' deaths, injuries, and destruction of entire buildings. In addition, an explosion in processing equipment or in an area where dust has accumulated may shake loose more accumulated dust or damage a dust containment system, such as a dust collector, resulting in the dispersion of additional dust into the air and may cause one or more secondary explosions. The history of devastating industrial explosions has proven that secondary explosions can be far more destructive than the initial dust fire or explosion. Now that we understand the combustible dust hazard, the next question is, how can we ensure a safe work environment when working in an area that produces combustible dust? The answer continuous strict housekeeping, and by following Wilson-Art's combustible dust program. Be assured, following Wilson-Art's preventive maintenance program is a top priority for Wilson-Art employees. Wilson-Art has implemented a combustible dust program that includes identifying and assessing dust hazards, recognizing possible ignition sources, identifying locations where dust may accumulate, and implementing hazardous dust control measures. For example, combustible dust generated by productions that have been identified at the Wilson-Art facility in Temple, Texas include laminate sander dust, which is both capable of exploding and can ignite or spark when exposed to heat, as shown here. The affected departments and areas are the sander, cut-to-size department, and the surrounding areas, including the ductwork. Mag-ox dust can also ignite or spark when exposed to heat. The affected department and area is the mixing room and batch mixing areas. As shown here, even steel shot can spark when exposed to heat. The affected department and area is the peener area. How do we control combustible dust hazards? The primary control measure is good housekeeping. Wilson-Art follows a daily, weekly, monthly, and quarterly housekeeping schedule in accordance with the department ISO cleaning procedures. Be quick to have areas vacuumed where dust has accumulated due to the job task being performed. When cleaning dust from equipment, ledges, fans, and other areas, avoid cleaning methods that can disperse combustible dust into the air. Using vacuum cleaners to pick up the dust is a very good way to eliminate the hazard. However, it is extremely important to ensure that the vacuum cleaner is designated intrinsically safe for the job and meets the standards for vacuuming combustible dust. In addition, ensure that all potential ignition sources are removed from the area or de-energized if there is the potential of creating a dust cloud while cleaning. Examples of ignition sources that have been identified through Wilson-Art's combustible dust program include electrical causes, hot work, and powered industrial trucks such as forklifts and lowboys. Steps to control ignition sources include reducing or turning off heat sources during cleaning operations, following Wilson-Art's hot work permit program, and by ensuring proper electrical bonding and grounding. In addition, safety managers will identify areas requiring special electrical equipment classification due to the presence or potential presence of combustible dust, and then ensure that the OSHA requirements for electrical installations in hazardous areas are met as required by the National Electric Code. In addition, Wilson-Art facilities use dust collection systems to remove dust from work areas. Dust collection systems refer to a combination of equipment designed to capture, contain, and pneumatically remove the dust from the processing equipment and surrounding areas. Regular inspection and maintenance of the dust collection systems, such as replacement of dirty filters, should also be performed. To illustrate the importance of inspection and maintenance of dust collection systems, notice in this video the fire inside a dust collection system and the unique fire behavior of a confined dust. During fire extinguishment, the water stream disperses more dust, even creating a Venturi effect, introducing more oxygen into the fire, which increases the intensity of the fire conditions. Then we see the explosive nature of the combustible dust.
Today we're reviewing Ruboc's new NA35 HD immersion separator system. It's a compact double stack design. What we have here is very maneuverable. We can outfit this with a 110 volt motor deck, a 3-phase motor deck. We also have an air venturi as well that we can outfit it with. It's a two-part system. The first part is your immersion system. It is a liquid chamber. It has a manual sight glass on the outside here, as well as one in the front as well. Gives us an indication of what the liquid is. We have our dispersion screen that's going to take the turbulent liquid bath and it's going to help the material submerge into that liquid so it does not escape the vacuum. Up above in this chamber we have the demisting area as well as a demisting pad. The air, or clean air, will then travel down into the back chamber, which has some hydrophobic filters down inside of here, and then you have your motor deck. With this design, you do have the option to add a HEPA or OPA filter past the hydrophobic filters should you need to purify the air for your environment. It's a very simple design. You have your liquid fill on the outside. This is designed to fit a standard garden hose. You can pump oil into it via that, or you can pump water into there. Your chamber for discharge, you can easily fit a 5-gallon bucket underneath, and you have a 2-inch ball valve on the bottom that allows you to remove the liquid and the solids once that you've filled this up. So this is a 3-phase system. It is our most powerful, extremely quiet, extremely maneuverable. As you'll see here, the turbulent liquid bath. It gives you an idea of what's going on inside of that door. So if you start to see that discoloration of that liquid or foaming, you would know that saturation has been reached and you would want to shut that down. Now all the hoses and tools are completely grounded and bonded, so you can simply attach your hose to the inlet and then you'll be able to vacuum. It comes with a complete assortment of tools to vacuum the floor. You can crevice tools to vacuum hard-to-reach areas. What's nice about this system is the way that you service it. When it comes time to removing the liquid bath, you can simply use a standard 5-gallon pail. You can slide it underneath. You can discharge into the pail. It also comes with a micron filter bag. You can add this filter bag to the discharge and with the sanitary clamp, so you would easily add this on here, put the sanitary clamp around it, and then put that inside of the bucket. And then when you release all the liquid, it'll sit inside of this bag. You can then disconnect the liquid, pull the bucket away, and then you can drain the bag and then empty that out as need be. So for this purpose, I'm just going to show you how it does empty. Drain the liquid, and you can have it come out as fast as you like. All the solids are going to be held down in the bottom, so as you're draining this, the solids are going to naturally be pushed out by the liquid that's inside of here. And you can do that until the bucket's full, and then you can remove the bucket. So this unit's built out of a compression cast composite. There is nothing on here that'll rust or dent. It is fully carbon impregnated, so it is completely anti-static. Every metal component of this is fully grounded as well, so you have a redundant source of grounding on the entire vessel. So you can check continuity from any metal piece on this unit at any time. And then you can also check with a megometer through the carbon impregnated part. So you have a redundant source of ground on the entire vessel as well as all the accessories. So the unit is fully grounded, fully bonded, anti-static, non-sparking by impact, so there'll never be a static charge generated by the vacuum or a static charge by impact on the vacuum. So this has been a review of our Ruvox NA35 HD double stack design immersion separator. Today we're reviewing an important safety feature required by NFPA 484 2019 edition. It requires you to have a separate bonding and grounding connection independent of the electrical system. So while this unit is fully certified and is fully conductive and grounded, you also have to add a grounding cable. So we do offer a retractable grounding cable with an alligator clip that will allow you to ground this to some type of earth ground. This will be independent of the electrical system. At any time you can do a continuity test from the end of this to the inlet of the vacuum, from the end of this to the end of your accessory vacuum hose, from the end of this to the electrical ground system, just to be certain that the whole entire vacuum is fully conductive. So again, this is a new requirement required on all brand new machines and also all machines out in the field. A very important one, make sure that your machine is properly grounded and bonded to protect your employee safety.